Essentially, you can automate the spear phishing process. You had to previously spend time learning about a person, studying their social media, targeting a specific attack against a particular person. Now you can do it at a scale of thousands of millions of accounts. And of course, people tend to click on links they get from their friends, family, bosses, people they know and recognize. And it's also true for cybersecurity experts. So you're definitely getting access if you send 1,000 links, and there is 10, 20, 30% chance any specific person clicks on a malevolent link. There is also capabilities improving in terms of bodies, not just brains. We're starting to see development of humanoid robots. The good application there, of course, is things like rescue robotics, but you quickly realize the same robot with a weapon becomes a robot soldier, and that process can be very well automated in terms of targeting and very efficiently killing humans. We also see a lot of creativity in those systems. They're super creative. It's easy to visually recognize progress in their ability to create something new. Then you look at human face. We are biologically designed to really understand human face as well. We see if something is off. I started this collection of progressive images with 2014, where we just learned to generate very low level grayscale, kind of low resolution image of a human face. And I ended once I could no longer tell improvements. You can continue this process for the next couple of years, but really we got to the point where it becomes very difficult to tell between what is real and what is artificial in this domain of generating human faces. But the same process is happening in every other domain. We learn to create absolutely novel and very high fidelity simulations, games, molecules, biological components, anything you might be interested in. There is probably a startup working specifically on trying to use AI to generate that type of creative output. So the good news is we're creating awesome tools. They're capable of doing a lot of thinking for us, a lot of physical labor, both cognitive and physical labor essentially will become free. And that leads to abundance. We can get pretty much everything we want for meeting basic human needs. We can make amazing progress in scientific discovery, in curing diseases and understanding science a lot better. And there is also this unknown unknowns possibility. Things could be very good and we can't even fully predict how great they may be because we don't have the super intelligent capacity to fully understand what is being potentially developed for us. Unfortunately, that's the last positive slide I have, because for every one of those really awesome things, there is a negative side effect. So free labor just means technological unemployment at huge scale, unprecedented scale. Almost everyone loses their job. If you're talking about, rescue robotics, again, you essentially talking about automating war and robot soldiers, killer robots. Just as in the previous slide, we also have unknown unknowns to worry about. Things could be really bad, and we cannot anticipate, predict, prepare, and test for those really, really bad outcomes. The good news is there is a lot of people who are now concerned about this. This was not always the case. This was considered a field which was science fiction just 10 years ago. But a lot of rich, powerful, impactful people, scientists, business people, politicians, at some point said, okay, this is something we should at least look at. And more recently, we've seen thousands of scientists, top scholars, Nobel Prize winners, Turing Award winners, all kind of agree that, yeah, there is some concern. They think advanced intelligence could be as dangerous as nuclear weapons, a weapon of mass destruction. And even more recently, there is thousands who signed letters saying we should pause any development of superintelligence until we can figure out what we're actually doing with it. So that's good news. What are they actually concerned about? If you look about the space of possible minds, we're kind of familiar with the human example. The tiny blue dot there can represent all human brains, but there is an infinite universe of possibilities. You can have animal brains, you can have alien brains, robot brains, brains of robots from aliens, really no limit on what is possible. And it is also true about capabilities of those brains. There is an infinite level of problem-solving ability, and humans represent a very static point in that space. So not only are there diverse capabilities, there are also diverse preferences, values. What is common sense to a human and seems like a very natural answer to many problems is completely alien to aliens, and the AI models we're creating in many ways are kind of like those aliens. They don't have built-in human sense. They learn on all sorts of random data from internet, and then we try to kind of filter out all the bad things after the fact. We're not changing the model. We are saying, okay, don't discuss this topic, don't say this word, but it's also just putting lipstick on a pig in a way. You're not really changing the product. You're trying to make the user interface a little bit nicer. So in my work, I try to understand exactly what problems are and at what stage are they happening. Are we talking about pre-training? Are we talking about in deployment? All of it, maybe at a later stage where users are interacting with it, retraining it. Because AI is software, you get all the standard software problems. You get software bugs, you get misalignment with software engineer versus what was actually implemented versus architecture proposed. But also there are very unique problems associated with advanced AI. We talked about ability to self-improve, redesign itself, and in that process, you can lose a lot of safety features. There is also possibility of malevolent design on purpose. If you have insider threats, if you have someone who hacked the otherwise perfectly friendly system and modified its goals, adding malevolent payload in addition to what the system was already possibly doing, I think that's the worst case scenario, because you still get all the other problems. If you're creating malevolent AI, you'll still screw up your design, you'll still have mistakes in your code, but now there is also this malevolent intent, and we don't really know how to deal with insider threats. If someone within the company is actually doing this, it's very hard to address in any meaningful way. And it doesn't have to be a malevolent actor. It could be someone who is bribed, blackmailed, and otherwise forced into doing this to the otherwise reasonably safe project. So specifically with neural networks, we're starting to observe that the problems fall into exactly the type of categories we see with human agents. I often say that children are untrained neural networks deployed on real data, and this is essentially a very good analogy for most people to understand what problems we are dealing with. If you're a parent, if you have children, you commonly know the difficulties of supervising them, of explaining generality to them. There are very good scientific papers mapping those typical human baby raising problems to problems we see with advanced neural networks. And I cite those two papers there. You can look them up. But basically, for any problem, there is a very scientific sounding problem you can learn about. So if you have an issue with a kid getting access to the cookie jar, instead of doing good deeds to earn a cookie, they just kind of hijack your candy bar. That's what we see with a reward hacking problem, right? So we need to avoid that. And of course, with advanced AI, you are the source of that reward, so the system would target you for hacking. I'm not going to bore you with every single one of those examples. If you're interested, definitely look up those papers and you will see the amazing similarities between how humans fail in their learning and deployment process and what we're starting to see a lot with artificial neural networks. I mentioned possibility of using AI as part of malware attacks and social engineering attacks. That is based on their amazing ability to copy style, copy visual, copy voice, video representations. And it's getting to the point where you can't really tell, even as a person whose image may be being copied and regenerated, you no longer know if it was a candid shot taken by someone at a party, then you don't remember it, or if it's actually generated deepfake. And the reason is, the moment you develop some sort of tool to be able to tell if it's a deepfake or not, that knowledge can be used to improve the next generation of deepfakes. So it's always kind of 50-50 adversarial struggle between two networks, one counterfeiting samples and one trying to tell are they real or not. An improvement in one means that the other one can also learn from that improvement and they always come back to this. I have no idea. It's 50-50. Now, if it's not at that optimum level yet, you can sometimes tell the picture is not quite right. There are artifacts in it, but overall, long term, we basically predict that you will not be able to tell whatever a full-blown video with sound with high resolution is real or not. And so just because you see some politician doing something with your own eyes doesn't mean they actually did it, and vice versa. They can deny a perfectly real video of them doing something nefarious just by claiming it's a deepfake. So with the latest model of selling AI as a service, essentially anyone can become an attacker. You pay a very small monthly fee, and you also have an option of going with open source, open weights models, and that means anyone can become an attacker. We already seen nation states use those tools to engage in espionage and other nefarious activities, but really anyone. Psychopaths, doomsday cults, militaries, anyone can use AI as a service. Just add your own goals framework to cause a lot of impact in a negative sense on cyber infrastructure and social engineering attacks, stealing not just commercial secrets, but stealing AI models, AI weights, and anything related to that. Now, we know about kind of standard malevolent attacks. People try to steal your cryptocurrency, people try to steal your data, private information. All of that is known to us, but the concern, of course, is the unknown unknowns. As the systems become more intelligent than the attacker, they switch from being tools to independent agents in that space, and that's where we're struggling to do much to prevent those attacks.